What's going on, everybody? It is Kistner again, and today we are going to study 5.2 properties of exponents and radicals. Now, we learned last time that exponents, rational exponents, fraction exponents, and radicals are basically the same thing, which means that their properties are going to be exactly the same. So, and we also learned that we can write any radical as an exponent. If it's the square root, we write it as 1/2. If it's the fifth root, we write it as 1/5. The exponent is 1/5, and that means all the rules and properties are exactly the same. So let's get into this. You'll be on page probably 118 of your student companion, somewhere in there, page 118, and let's get started. So here's something that will not be in your book, in your student companion, so just watch this. These are good things to know and to sit down and to understand, write down somewhere. You can screenshot this or do something that will help you remember these. So a lot of these you'll know. The product of powers, and we've already talked about this multiple times, but they're just now showing it to you written out in our books. See, a to the m times a to the n equals. Well, a lot of these we won't have to actually work out, but if I have a squared times a cubed, if I wrote those out, I would write down the two a's, that's a squared, times, then I write down three more a's for the a cubed, and I now count 1, 2, 3, 4, 5, a to the fifth. But that's just 2 plus 3. So the rule here for product of powers is that a to the m times a to the n is you add your exponents. You multiply similar bases, the same base, you add their exponents. And they do it over here with rationals. 4 to the 2/3 times 4 to the negative 1/3. It's 2/3 minus 1/3 gives you 4 to the 1/3 power. Same concept here. If we do the division, I could do it with x squared or x cubed divided by x, just x is fine. So x to the first. That's the same as x times x times x all over x. One of the x's cancels, and I'm left with x squared. Up top, x times x is x squared. And all that means is it's just subtraction. And that's what division is. If you divide a to the m by a to the n, so that could be any number to any number divided by any number to any number, you just subtract the exponents. So when you multiply bases, you add exponents. Divide bases, you subtract exponents. You see that happening over here. 3 to the 4th divided by 3 squared is 3 to the 4 minus 2. 3 squared is 9. Power to a power, same kind of concept. We could write it out. If I did a squared to the third power, that's like saying a squared times a squared times a squared. And we've already said when you multiply bases, you add the exponents. 2 plus 2 plus 2 is 6. A to the 6th. So this rule will be you multiply, which is why this works, where we figure out a power to a power. We get just that squared. We used that a lot last section. The power of a product, so the power of a power is you multiply the exponents. The power of a product, you can distribute. Each number gets raised to that. We used that last section as well. 16 to x to the 1/2 power is the same as 16 to the 1/2 x to the 1/2. Well, 16 to the 1/2 is just the square root of 16, 4, and we have x to the 1/2. Now this is a new one. A to the negative m. Okay, a to the negative m. So I show this example a lot, and in one of our classes I listed, 2 squared is 4, 2 to the first power is 2, 2 to the 0 power is 1, and you could go up. 2 cubed is 8. Now, we're multiplying by 2 when we go up, right? Everything's times 2 when we go up a power. But if we go down a power, as I'm going down a power, it's just the same as dividing by 2, right? 4 divided by 2 is 2. Divided by 2 is 1. So, in theory, if I go down one more power to negative, and I keep that going down pattern going, that's dividing by 2. Well, that's going to be 1/2, better known as 1 over 2 to the first. 2 to the negative 2 is 1 over 4, also known as 1 over 2 squared. So if you notice, the exponent is staying the same, the sign is changing, and that's the rule. That's the new rule. We've covered this in Algebra 1 if you had me, but let's go back over it. If you have a negative exponent, you just put it on the bottom of a fraction. And it works the same way if you go the other way. If I have 1 over x to the negative n, and I want to move that up top, it's just x to the n. It just means reciprocal. Okay? It's just a reciprocal. A negative exponent is just the reciprocal of that. Okay? So let's use these. That was a long intro, I'm sorry, but let's just use these powers, sorry, these properties to answer some of these examples. So example 1, how can you rewrite each expression using the properties of exponents? Okay, so, all right, sorry about that. I had to pause it for a second. Now, we're going to rewrite this just so we can use it down here a little bit. Now, we're going to work inside out here. That's how I want to. That's how I want to work. So I still have this parentheses, and it's still 1/2 out here. Now, inside, I'm going to choose to write 32 to the 2/5, which is really the 5th root of 32 squared, or vice versa. You can be the 32 squared or the 5th root of it. But I'm going to write it using fractional exponents. This is that part. But with the fractional exponent, I'm going to have 32 to the 1/5 power all squared. Now, I chose to write it this way because I know what 32 to the 1/5 is. 32 to the 1/5 is 2. 2 to the 5th power, 2 to the power of 5 is 32 to the is 32. So 32 to the 1/5 power is 2. So I'm going to have 3 over 2 squared, all raised to the 1/2 power. Now, using our properties of exponents back here, mainly this one, sorry, no, this one, if you have an exponent, it gets everything inside the parentheses gets that exponent. So here, I have an exponent, the 1/2, everything inside gets that exponent. So we're going to have 3 to the 1/2 power, all over 2 squared to the 1/2 power. Better known as just 2, because 2 to the 1/2 is 1. And 3 to the 1/2 is the square root of 3 over 2. That whole thing cancels down to the square root of 3 over 2. All right. Long example because it had a lot of different steps. We'll do part B in class next time I see you. How can you rewrite this expression in example 2? It's the 4th root of 81 a to the 8th b to the 5th. Now, we've done this one multiple times, something very similar. So the first thing I'm going to do is 81 a to the 8th b to the 5th, and I'm going to put it all to the 1/4 power, because the 4 here can become a fraction as 1/4 and become your exponent. So really using the property, the product property, sorry, that's what I'm trying to say, you get 81 to the 1/4, a to the 8/4, b to the 5/4. Now, we're going to do something just a little strange here when we get down to part B. And you'll see, and I'm going to separate it and do that. But 81 to the 1/4 is going to be 3. 3 to the 4th power. You can think of it as 9 times 9. That's 3 squared times 3 squared. So that's 3. Then you have a squared. 8 over 4 is 2. And this one, let's think about this. B to the 5/4 is like saying b to the 5th power all to the 1/4 power. Now, if I expanded that out, that's b times b times b times b times b, and I'm taking the 4th root of it. You can also look at it as b to the 4th, that's these 4 times b, all to the 1/4 power. So I expanded it, and I'm taking the 4th root. I just separated it. And the reason I did that is now I have b to the 4th to the 1/4 times b to the 1/4. And this cancels. That's b to the 1st power. Okay? Times b to the 1/4. So when I get done with all of this, I have this b here, and I have the fourth root of b. So the shortcut there is you can always take one less than your bottom, or you can take as many as your denominator is out and leave whatever's up there. So if this was a sixth power, this would be b squared. Okay, we'll do that again down here on letter B. That was kind of a little confusing. We're going to talk about that one again for sure because of that, because of this part right here. So here's another concept page. Product property of radicals means you can separate the radicals. The nth root of a times b is the same as the nth root of a times the nth root of b, and because that's the same thing as the fractionals. And division works the same way too. It's the same thing as we've already learned. So we're going to do a couple examples that way, and then we'll be done with this video. So I have the fifth root of 7 over 16x cubed. Now, this is the same thing as the fifth root of 7 all over the fifth root of 16. X cubed, sorry. Okay. Now I'm going to write this in a special way. This is where it gets a little bit more confusing. I'm going to leave the fifth root of 7 up top. Okay. And I have to rationalize this denominator. I don't like the fifth root down here. Just like we don't like square roots in the denominators, we don't like fifth roots in the denominator. So what I need to do is to get rid of that. Now visually, it might make more sense to rewrite it as 7 to the 1/5 over 16x cubed to the 1/5. Because now I need to multiply the top and bottom by something to get rid of the 1/5. And remember, when you multiply bases, you add exponents. So instead of having just 16x cubed to the 1/5 power, and I need to multiply it times something, I'm going to multiply this denominator, okay, by itself to the 4/5 time. Okay, I have to do it top and bottom. Now, the reason that works is 1/5, we're going to multiply these two, and the 1/5 and the 4/5 become 5 over 5. This is going to be the fifth root of 7, that's this one, times 16x cubed, all to the 4/5 power, all over, remember when you multiply these, you get 16x cubed to the 5 over 5, which is just 16x cubed. All right, now, this up here is the fifth root of 7 times the fifth root of 16 to the 4th power, x to the 12th power. The 4 comes into those. All right, this is going to get kind of crazy. So bear with me. This will be the last example that we do, just for time constraints. Still have the fifth, oops, don't have my denominator written yet. 16x cubed. Now, I'm going to go over here. The fifth root of 7 times. All right, the fifth root of 16 to the 4th is the same as 2 to the 4th to the 4th, better known as 2 to the 16th. Because 2 to the 4th, you multiply those, you get to the 16th, x to the 12th. Now I can take groups of 5 out of this. I divide my exponents when I'm taking the fifth, because if I rewrote this, this would be 16 over 5 and 12 over 5. So I've still got this denominator. This is a messier problem than I expected them to give you. You have the fifth root of 7 times. Now, 16 divided by 5 is going to be 3 with a remainder of 1. So this will be 2 cubed. Okay, that's the 60. That's this part. The 16th, the fifth root of 16, 2 to the 16 was 2 cubed, and then 5 goes into 12 twice. So x squared all over, or sorry, I still have the fifth root, and what's left? There was 1 2 left, and 2 x's left. All right. Now, I still have 16 x to the third. So we're going to get even a little bit more in depth here. 2 to the third is 8 x squared. And since these are both fifth roots, 5 and 5, I can combine them to be the fifth root of 14 x squared. All over 16 x cubed. The 8 and the 16 cancel to become 2. The 3 and the 2 cancel with our subtraction. This goes away. That's just x. So my final answer is everything that doesn't have a line marked through it now is the fifth root of 14 x squared all over 2x. And that's the end of that problem. And that was a ridiculously complex problem for it to be your first example. And I apologize for that, but that's what your book does. I'm going to stop the video here because your mind's probably a little confused. Go back and rewatch that problem. There's a lot of little tricks that I use that I will talk about next time I see you in class. And I hope you guys are enjoying your night or your day or whatever it is. And this is Kistner out.